Hello and good evening to today's live stream. So hopefully if you've followed the first two live streams, your build should end up something like this, with all of the columns and all of the rows now soldered. So now we're ready to program the board. So I'm just going to wait and see if anyone shows up before continuing. Hey, we have someone watching, that's good. Okay, I'm just going to wait a few minutes more to see if anyone else turns up, and then we'll move on to starting the programming. Okay, let's continue. So I'm now going to switch to screen capture mode, so it'll capture what's on my screen. So now you should be seeing what's on my screen. So what we need to do first is to make the layout that we have. So you want to go to your keyboard layout editor, and then hang on, I'll just had to disable the Flux app because it messed with the brightness of the screen just there. So what you need to do is you need to make the default layout that you're going to have for your key map. So if you have a numpad, a full size, 96%, you'll need to create your layout on the keyboard layout editor. So then once you've done that, you just need to click on raw data and then copy all of the information in the raw data file, because this is what we're going to be then using to then program the keyboard. So you just need to copy all of that data, go onto the keyboard firmware builder website, which is kbfirmware.com. So then you want to just paste in that layout and then click import, and that will bring your layout onto the system. So then we need to set up the rows and columns. So in this example, we have obviously got 5 rows and the 15 columns. So in fact, I'm doing it in 13 columns. So I'm going to bring that down to 13. So leave the diode direction as column to row, that's what's normal. So what we need to do now is then at the top you'll see the board size plus or minus, so that just zooms in and out. If you have a large board, then it'll allow you to zoom into what you need, and you also have a button called flip. What this means is that because your wiring would have been on the back, that's then opposite to how we would look face down on top of where the keycaps are. So what we need to do is we need to flip. And then that will then match the layout that we have for the wiring. So you've got to always remember that the columns and the rows all start at 0. So as you can see, it starts at 0 at the top and goes to 13, and starts at 0, goes down to 4. So following your key map, what you then need to do is specify the exact column and row per switch that you've got, if this isn't correct. So you see at the bottom it says change the position of the selected key. So you can select in your key the exact column and row that is needed. So for this first one, for example, the switch that we'd have for shift is currently on column 1, whereas it's wired up to column 0. So we need to change that down to column 0. So the second one is that one. That's going to need to be column 1. That's column 1. And this next one, that's 2. That needs to be 2. This needs to be 2. That's 2, and this is also going to be 2. So then you need to just follow down each of these and make sure that your configuration that it's shown is matching what your key map is, the actual matrix that you've built. So then that is now what my wiring is. So this should definitely now correspond to your matrix that you've wired out. Obviously with the flip on board, which basically, as I said, just flips it over, because we are looking at the back of the board when we do the matrix. So now if we go to the pins, if I switch back to the camera just for a second, so this is what you should have, something similar to this. So that's all your rows and columns that are on the pinouts, because these are what we then need to then load into the kbfirmware.com, so to then make sure that the correct rows and columns are programmed to the correct pins. So I'll switch back to the screen capture. So you need to select your controller. So in terms of the postage board, I know that it's a U24. So, and I need to configure the row and column pins. So my row starts in B6, then B2 for the second, D0 for this one, D1, then finally D2 for my last row. Then my columns start at B7, then C6, C7, D3, D5, B5, B4, D7, D6, D4, F0, F1, F4, then finally F5. Now my board is going to have a caps lock LED, so I need to specify the pin down here, which is B1 for my caps lock LED. So if you do want LED pins on your board, then you can obviously set them here. Obviously most hand-wired boards aren't going to have backlit LED, although if you do obviously have the backlight LED, you can obviously select a pin here. So now we can move on to the key map. So this is just the basic key map. So I'm going to just basically leave mine as it is, but the main thing that I would say to look for And we're still, there we go. We're still flipped over from when we were doing the, getting the switch matrix set up right. So what we need to remember is that you see this by saying a backslash. If this was an ISO board, we'd need to change this. You see down here the NUHS and NUBS. That stands for the non-US backslash and non-US hash. So if you are using ISO, you would change these to, obviously that would be your backslash, so that would be the NUBS, and then obviously if you would have your hash key next to your ISO enter, so that would be the NUHS. But any of the other key layouts, it doesn't matter what your OS is, so like this KC Grav key, that would still be KC Grav even if in the UK or in other ISO languages or whatever. So because it's your OS itself would then translate that key code to the required character for that language setup. Obviously in here you do have layers, but for now we're just going to keep it basic with only having the one layer, because if you add more layers it's obviously more complex, and if you do want to add in more layers then obviously you would look at that yourself on the QMK firmware documentation. So for now, you'll just need to leave the next two settings because they're mainly for if you want to set up macros or other things like that. So we come to this one which is settings. So at the bottom where it says check errors and warnings, that will tell you if, for example, you've made an error in your wiring and you've got two switches that share the same pin configuration, so that'll tell you there, because obviously you don't want two switches having exactly the same pin layout. So you'd call your layout name. So mine is just going to be Handwire 60%. You select your bootloader size depending on what your controller is. So I know that the controller in the postage board is an 80 mega 32U4. So as you can see, that's the 4096, so I'll leave that at 4096. I haven't got any of the RGB LEDs and I haven't got any backlights. So you can click your save and that will get you a JSON file that you could then use in your keyboard layout editor. So what we have down here is a compile. So you can download the .hex and flash that straight away, or you can download the zip files. So what we're going to do is we're going to download the zip files, and then I'm going to open them up and then give a overview of each of the files in this zip file and how they relate to each other. Because when you compile all of those files together, those are what generates your hex file that you then flash to your microcontroller. So we're going to click that and download the zip files. Then we're going to open it. So here is your QMK firmware. So this is basically some of the files that aren't needed to obviously flash your board that you've just created. So the files that we really need are in keyboards, KB, and those are your files. So what we need to do is first, I'm assuming that you will already have the, okay, so first you would need to set up your Ming64, which is how you would set up your build environment. There is a guide on how to set this up on the QMK firmware page, so I encourage you to go and read through that and go through the steps themselves. There was a few months ago a tutorial that was actually done on the Top Clack YouTube channel, so you can also then follow that if you want to know how to set up your build environment. So basically you'll download the QMK firmware folder to your hard drive. So then what we need to do is we need to then copy this KB folder into the QMK firmware folder. So I'm going to choose keyboards, Handwired, and then get a new folder in here. So this is going to be Handwired 60%. So there it is. So then now I'm just going to copy all of these, because these are the files that we need, and put them in that Handwired 60% folder. So the reason why I've done this is that when I go to compile, this is going to know exactly where to fetch the files. Okay, so now I'm going to go through each one of these. So we'll start with the rules.mk. So I'm going to open that with Notepad++. See, I already have a lot of them down here, but I shall just exit these for now. So this is going to be your rules.mk. So this basically tells the bootloader exactly what your MCU is. So it tells us what the CPU speed, what the clock speed is, the clock frequency, etc. So you'll see at the bottom that it has some options that say the enable options. So obviously you'll put on there if you want RGB if you want backlight, if you want RGB light, if you have got a speaker set up that you want audio out, or things like that. So that's just where you set those simple options there. So the next one, your make file, you leave that, because that's what you're going to create when you compile. So the next one is a keyboard kb.h. So what this basically is a representation of the electrical matrix and how this maps to the physical matrix. What I mean is that you can have your, obviously the wiring for your switches does not have to be in the normal rows and columns that most modern boards are wired in. So if you have a look at some of the very old vintage boards, for example, you might have, say, F1 and F2 at the top row, and then you might have F3 and F4 down in, say, row 3 or row 3 or row 4, for example, because to get around the fact of having NK rollover, they used the matrix in sort of an odd configuration, so that basically meant that they didn't have to use a diode with every switch. So if I actually open up one of these, let me have a look. So if I open up one of the vintage keyboards that I'm currently working on at the moment, so that should be now. So you've probably seen my Handwire board that I have. So this is the KB.H from my Handwire board. So that's how it looks like with the Handwire board. So you can see how we've got K0001 at the top, but then up to K097. But then if we open up the actual key map for this board, you can see that was what the key map looks like. So it's not in a traditional sort of rows and columns like you would normally have. So it's something to look out for if you do decide to obviously convert your vintage keyboards, which I might do a small series on in the new year as to how you would go about converting a vintage keyboard that is not XTR AT compatible. So if, say, it uses an odd protocol or for some other reason isn't directly compatible, then you'd have to obviously wire out basically just figure out what the matrix is and then try and program it yourself onto an external MCU. So we'll go back. So this is, like I said, this is what the KBH is. And I'll also show you my UK78 as well as another example. So is that down here? That might not be down here because I think that was just on the that's on a different part. But anyway, that will have, you notice that on my UK78 I have a separate numpad that's separate to the main board. So electrically we'll see that numpad separately to the rows and columns, but you can define the key map to have the numpad continue along your actual physical rows and columns, despite it not being continuing on the electrical rows and columns. So I'll open up the key map now for this board. So your key map is always in key maps default because that's just where it would normally look when obviously when you're compiling your board. So it's best to always leave it in the key maps default layout. So this would be the default layout for the 60% that we've got. Obviously these ones below are all the different layers. So at the bottom, here's where we have our LEDs. So you'll see where it says DDRB port B1. So port B1, if you remember, is what we said for our caps lock. So where it says port B, that will also always be the letter and the number that you've specified as to what your caps lock is. Obviously we can have your num lock, your caps lock, your scroll lock, and we don't bother about the compose and Kana because I think those are mainly for either Mac, or I think the Kana is probably for the GIS layout, perhaps, I don't know. So now I'll open up the other two folders. So we've got KBC, which is just simple really, it just says include KBH. So KBH is what is the main file because obviously that defines exactly where the switch positions are. So you can't program your key map to a switch that doesn't exist. So you'll see that these gaps down here, so the gaps correspond with the KC no in the ones below. So that's basically the way that the files are interlinked. You'll see at the top that it says include KBH. So what you need to be looking for is if you are having an ISO layout, there are different key codes for your different locales. So if we go up to the KMK firmware folder, you'll see down here that so in Quantum and in keycap extras, you'll see here all of the different extra keycap codes. So if we open up, say, we got keycap UK. So if we are open that, and you see this is all of the Alt-GR codes. So you've got UK hash and UK backslash, which is, as I told you before, is the NUHS and NUBS. Then you've got your shifted characters, which are obviously defined to the different the different combinations of the code, so the left shift and the code. You also got the euro symbol there, and so all of these are the different codes. So if you want to include this on your key map, you just got to see where it says key map UKH. So you've got to put basically include key map UK.H, and then that will include these codes already for you. You don't have to define them yourself. So you put that up here. So include key map UK.H. So you do that, and then that will basically then copy all of these defined codes into your, when you go and compile them. So I'm going to save this keymap.c now because I've modified it. And now we're going to do and compile. So this is the, basically it's like a Linux style editor. So I'll go up and see, because I've already got. So first of all, we need to go into the QMK firmware file. So we'll just change directory into there. So I've been making a board called RS Cherry, which is for one of the vintage keyboards. So we now want to make in Handwire / Handwire 60%. And then hopefully this should make your build file. Okay, so it's not like that. It's because we're not changed into the, so we need to CD into the correct file folder. So probably didn't like that we had the space between the 60%. So I shall go and actually rename that now. So I'll close down all of the don't need that. So keyboards, Handwired. Let's rename that because it probably didn't like this, having that space bar symbol there. So we said Handwire, but it's in actually Handwired. So that's probably why it didn't like that. So Handwired / Handwired 60%. Okay, let's see if this compiles. have to do shift and insert for paste. And if this doesn't work, then I'm just going to copy it straight to the keyboards folder and maybe it'll work then. No, it doesn't like doing it. Okay, so what we have to do is we have to cut it from the keyboards and then just do it directly in here. So handwired 60%. Okay. As you can see, we've got an issue. Because we've got that make file in there. I don't think that's... No, make files there, so it should be alright. Let me try and update the Q&K file firmware. Maybe that is a problem. Sometimes you have to do this if the thing is not updated. So we shall update everything. Sorry for this, guys. I didn't envisage that I would need to do this, but it seems that it's not liking it for some reason. We're going to click N because I think I've got all the drivers anyway. I'm not building any AVR boards, so I'll click No. Okay. Let's see if that gives us any better results. Right, instead of doing that, let's go back to the kbfirmware.com and download the hex file, because that should then be what we would use to actually flash the board with. I would have obviously showed you this, but for some reason it wasn't compiling properly, so I'm going to just copy this, go back to the Q&K firmware, paste it in here, then I will need to connect up the board. Now what we need to do is load up your local file. So I'm going to select Handwire 60. Then what we need to do is we need to put the microcontroller into the flash mode. So what we need to do is we need to just short out a couple of pins to reset the MCU and to put it into DFU mode. Which then shows there, so then I should be able to flash this, which should then have flashed the layout that I need. So now I'm going to look on a keyboard tester and just check that everything is working correctly. So then we've got 1, 2, 3, 4, 5, 6, 7, 8. That's spacebar, then R Alt. Let's open up menu again, and Control. So everything is working correctly. The keyboard has been correctly flashed. Sorry that I couldn't compile with the QMK toolbox, but I've done that now. So I shall go back to the camera and then that will show you the layout that I have. So this should be back to normal now. Okay, so that's my layout. As you can see, that's in SA Industrial because that's for the build that I would be doing. So I hope that that's been helpful to people and that they can now go and make their own hand-wired boards. As I said, this is the last one, the last in the Helping to Handwire guide, so there won't be any future streams probably until the new year, where, like I say, I'll probably do a short guide again as to how to wire up a vintage keyboard that either has no controller or has a the protocol is not XT or AT layout, and so therefore it's not easily converted. So if no one's got any questions or anything, then I shall be ending the stream. So I hope that it's been very helpful for you, and that hopefully this encourages you to build more of hand-wired boards. So I shall see you in the new year if I do decide to do the next streaming series. So have a good few months and build some boards, and I'll keep a watch out for any hand-wired ones. So I'll end the stream now. Thank you.